The question says, how many moles of sodium trioxocarbonate 4 are there in a 25 cm cube solution, which required 10 cm cube of 0.05 mole per dm cube hydrochloric acid solution to neutralize it? Solution. The first thing to do here is to write out the chemical equation. Here we have the acid reacting with the base to undergo a neutralization reaction. The acid is hydrochloric acid, while the base is sodium trioxocarbonate 4. Since the base is sodium trioxocarbonate 4, that is a carbonate compound, our product will include carbon dioxide apart from the salt and water that will be given at. So let's go on. We have the acid HCl reacting with the base sodium trioxocarbonate 4 Na2CO3 to give the salt. Here is sodium chloride. We have water, and we also have carbon dioxide. Now, after writing out the chemical equation, the next thing to do is to check if the equation is balanced. Looking at this equation, we will discover that the equation is yet to be balanced. So let's balance the equation. We have 2 atoms of sodium present here, and we have 1 here. So let's add 2. So sodium becomes 2. Let's check for carbon. Carbon here is 1, and here in the product side carbon is 1 as well. Oxygen in the reactant side is 3. Here we have 1, we have plus 2, that's 3. So oxygen is balanced as well. Let's go back to hydrogen. We have 1 atom of hydrogen present in the reactant side, while in the product side we have 2 atoms of hydrogen present. So to balance hydrogen, we'll be adding 2 to the reactant side. So we have 2 atoms in the reactant side and 2 atoms in the product side as well. And for the chlorine, we have 2 atoms of chlorine present in the reactant side, and in the product side we have 2 atoms of chlorine present as well. Then we can say the equation is balanced. Since the equation is balanced, the next thing to do is to write out the formula we'll be using. In any question that has to do with neutralization reaction, the formula mostly used is CAVA over CBVB, which is equal to Na over Nb. Yes, this is the formula that is mostly used in a question that takes this format, and that's what we'll be using here as well. In this formula, Ca is the concentration of the acid, Va is the volume of acid, Cb is the concentration of base, Vb is the volume of base used, while Na and Nb are the number of moles of the acid and base respectively. Let's proceed. The next thing to do now is to write out the values given from the question. The reason we are doing this is to make it easier for us to get the unknown. So let's start. The first data we have here is Ca, the concentration of acid. So from the question, Ca is given to be 0.05 mole per dm cube. Then Va is given to be 10 centimeter cube. While Na, the number of moles of the acid, this is usually gotten from the equation, and that is the coefficient of the acid in the equation. The coefficient here is 2, so Na is given to be 2. So for Cb, concentration of the base is unknown. Vb is given to be 25 centimeter cube. While Nb From the equation, Nb is given to be 1, that is the coefficient in front of the base. So having done this, we'll discover that the unknown here is the Cb, the concentration of the base, and that is what we are being asked in the question, saying that how many moles of sodium trioxocarbonate 4 are there in a 25 centimeter cube solution. So we need to know the molar concentration of the base, and we'll be doing that by making Cb the subject of formula. So we have Cb to be equal to times Nb divided by Vb times Na. So let's substitute the values. We have Ca as 0.05 mole per dm cube times Va 10 centimeter cube times Nb, which is 1, divided by Vb 25 centimeter cube times Na, which is 2. So this gives 0.5 divided by 50 mole per dm cube, which is equal to 0.01 mole per dm cube. With the calculation we just did now, we've calculated the number of moles of sodium trioxocarbonate 4 that will be present in the solution, which is 0.01. That is 0.01 moles is present in 1 dm cube of the solution, and that answers the question.